Welcome to a new exercise. We continue the study of objects moving under the influence of gravity. In this case, we're going to study a ball that is thrown and the only information available is the time. Let's have a look. A person throws a ball straight upward, which hits the ground 4 seconds later. Find the initial velocity of the ball. We start by drawing our coordinates. Our y-axis is pointing up. Down here we have the ground, which corresponds to y equals 0. The ball is thrown upward with some velocity v y0, which is the quantity we need to find, and the only thing we know is the time. So it says that the 4 seconds is what it takes for the ball to go all the way up, reach the maximum point, which in the previous exercise we call the max point. This is our max point, where the ball will stop and will come back to the ground. For this, the ball took 4 seconds. There are only 2 formulas that involve time, which is the information that we have. That means it's one of those that we have to use. Let's write the height of the ball to be the initial height plus the initial velocity in the y direction times the time minus 1/2 g t squared. The initial height is 0 because the ball started at y equals 0. It was thrown from the ground. It will go all the way up and then will come and hit the ground again. So here is the condition of the ball hitting the ground again. We set the height to be 0. Okay, so the height is 0 twice in this problem. First, when the ball is just thrown, which is not the one that we care, it will go all the way up, it will reach the max point, come back and hit the ground again. So we write this term is 0 plus Vy0, which is the quantity we're looking for, times the time minus 1/2 g t squared. We can now solve for this equation for Vy0. Let's pass this to the other side of the equation. We get minus Vy0 t equal to minus 1/2 g t squared. Now we divide on the 2 sides by minus t. So we get rid of this minus and we get rid of the t. With this we get V0 is 1/2 times gt. So the minus went away when we divided by that minus, and the t squared became just t when we divide by the t on the left. So this is 0.5 times acceleration, which is 9.8 meters per second square, times the time, which is 4 seconds. This is the time that it took for the ball to hit the ground again. And let's see what we get. 0.5 times 9.8 times 4, 19.6, roughly 20 meters per second, because what we're looking for is velocity that can also be verified with the units. And there we have it. This is the initial velocity given to this ball so that it will go all the way up to the max point and come back, hit the ground again after 4 seconds. In the next exercise, we're going to start throwing things out of buildings, so make sure that you don't miss that.